All right, our next test is going to be the iodine test, which only detects the presence of starch. Starch is a polysaccharide, so many sugars linked together, used to store energy in plants. So we'll go ahead and test that. For this iodine test, we can determine if starch is present by color change to a dark bluish black color. Okay, so if it's negative, you won't see that black color. So for this test, since it doesn't need to be heated up like the Benedict's, and I'm also going to test some bulkier material, it's just easier to perform that in a well plate so that I can easily clean it out rather than trying to dig out chunks of bread from our test tubes. First, I'm going to start with the negative control. Right, I'm going to go ahead and add that to the first well. Right, so I'm just adding 1 milliliter. Next, I'm going to add a positive control, which will be 1% starch solution. Next, I'm going to add glucose solution to the third well. Right, and then I'm going to test some different foods. We'll do milk, onion, banana, potato. Let's test a piece of bread. I'm going to test some paper too. Go ahead and test sucrose too. Then I'm going to add a drop of iodine solution. Tap in the side just to mix it up a little. You can see one very obvious change in our positive control, right? All right, so the first well is water. It did not change to a bluish black color, so that we know our negative control worked. Positive control starch solution appears to be a bluish black, so our test is working. Glucose, again, that's a monosaccharide. That is negative. Sucrose, a disaccharide, that is also negative. Milk. What do you think, negative or positive? So again, just go back and compare to the controls. All right, and the next well here, we have onion, and we have banana. So it didn't mix very well. Let me just mix it up for you. That's looking very black. Next to it is the potato. That's also black. Bread, where I added the iodine drops to the bread, it turned black immediately. The same with the paper. Okay, so again, the color change to black indicates the presence of starch. So for the next portion of this exercise, we're going to discuss lipids. So remember, lipids are compounds that are insoluble in water, and they're soluble in nonpolar organic solvents such as ethanol. Triglycerides consist of fatty acid tails, 3 fatty acid tails, that are covalently linked to glycerol. So within those fatty acid tails, there are long hydrocarbon tails. Those are very nonpolar. Right? So remember, nonpolar substances do not like to dissolve or disperse in water. right? So lipids are insoluble in water, nonpolar, and hydrophobic. So let's go ahead and see what happens when we add oil on top of water. All right, so I'm going to start with a test tube. I'm going to go ahead and add 3 milliliters of water. And then next I'm going to add vegetable oil. All right, so I have 3 milliliters of water. Added 20 drops of vegetable oil. All right, so you can see all of that oil sitting on top of the water. Very hydrophobic, insoluble in water. All right, so now let's create an emulsion. We can do that by mixing it. I'm going to use this vortexer behind me. But you see the nature of the triglycerides in the oil. Since they're so nonpolar, they're going to again separate from the water. So we see our layers form again, the vegetable oil on top and the water on the bottom. Okay, so next I'm going to add this Sudan bread. Now, Sudan bread is nonpolar like the vegetable oil. I'm just going to add 3 drops of that. It's very concentrated. So let's take a look at where it's found. All right, as you probably expected, since the Sudan bread is nonpolar, it's going to sit in that layer where the vegetable oil is found rather than go to the water layer. All right, so I'm going to go ahead and vortex that. We'll create an emulsion. But we see our layers form almost instantly again. That oil with the Sudan, both of them are very hydrophobic. They don't like that water layer. Now let's see what happens when we add detergent. Detergent is an emulsifier. And then I'm going to vortex it to mix it up. Okay, let's see if those layers form now. Right, so we have some soapy suds at the top, but there is no separation of the oil and the water. We can tell because that oil would be with the Sudan, which is red. Now we don't really see 2 separate layers. Okay, so what's special about detergent? How does it act as an emulsifier? So emulsifiers are components that have a polar end and a nonpolar end. So the nonpolar end of the emulsifier is going to interact and surround the droplets of the oil, while the polar end is going to interact with the water and disperse that oil throughout the water. Okay, so that's why we don't see those layers of the oil and the water separate. If you have any questions, feel free to email me. Keep a lookout for your post-lab questions or your quiz on D2L. Have a nice day.